the second topic is PDU set handling for release, so this is a topic that comes from release 18, and then we did some enhancements during release 19. By the way, in the slide sets, I have the names of the experts from Nokia who have been contributing to these topics and have helped me prepare these slides. I had Ghazi in the previous one and Serhan here. And so this one is maybe harder to tackle in 5G MAG, but I would like to hear input, and it was I thought it would be good to at least present what has been happening. So like I said, this was enhanced during release 19, and what this slide set talks about is what was done. So what is PDU set handling in general, and what was done during release 18, and then what enhancements were done during release 19. So we have so basically what PDU set handling brings to the 5G system is that it provides some more application awareness to your RAN, which allows more optimized handling of the packets that are going over RAN, so that your application can overall benefit with, for instance, what packets are dropped and what packets are kept, or what packets are delayed over the network. So what the how the system works is that you have an XR application server, which might have different kinds of sources of data. So you might have video, music, or drone data, and over the service data flow, what you have is a PDU set data, and this PDU set is basically one application data unit. For instance, it could be one frame, and then you can mark these with additional information that will go over that then gets delivered to your UPF, which can provide this information to the RAN for proper handling. So I'm going to go to so that I have all the information here and actually sees how this happens. So you have, for instance, these different types of PDU sets. And when it reaches the UPF is what is responsible for sending the data downlink over RAN. It divides them over different cost flows. Each cost flow has its own properties. So you can, for instance, have for a particular cost flow a PDU set delay budget, a PDU set error rate, and then your one PDU set can be multiple packets. So for instance, in RTP flow, you can have one PDU set as a single frame, and within that frame, because that frame is going to be fragmented, so your each RTP packet will be a PDU. For instance, what you would want is that if you're so one basic example would be that if you have congestion and you're dropping packets, you would like that the packet losses are kept in a single frame, so you don't have like one packet missing from each frame, and also that you would like, for instance, your iframe to be delivered, but you can always lose packets from the p frames, which are not as important. So what this PDU set framework does is that you can add additional information to each PDU set. This additional information can be your PDU includes your PDU set sequence number. So because these are in order, you would have a PDU set sequence number. Within the PDU set, you would have a PDU sequence number. You would also have an end PDU of the PDU set, so you know that the PDU set has finished. This is the last packet from it. You can have the number of PDUs in the PDU set. You can have the PDU set size in bytes. And this is used for instance, resource allocation. And then you have a PDU set importance. And the PDU set importance, which is range of 0 to 15, is what decides whether you would, for instance, drop a packet in case of congestion or keep it. With the lower PDU set importance, meaning higher importance packet. Then, so what the UPF does is that it takes, so this information we added into RTP header extensions. And what the UPF does is that it translates that information into into a GTPU header so that the RAN can read it. And what the RAN does is that then optimize scheduling, buffering, and discard based on this information before delivery to the UE. and you have a happy user on the other end. Okay, so during release 18, we had the RTP header extension already in place. It had the same fields that I just talked about, so that you have a way to identify all the packets that belong to a single PDU set. So for instance, all the packets that belong to a single frame. Then you also know when this frame or this PDU set has ended. You know how many packets or PDUs to expect, and you know what size it is. And then you have the importance. You also have an end of data burst. So for instance, if you have bursty traffic, you would know when the burst has ended and when there might be a bit of a quiet period following after that. During release 19, we added some new header extensions. This includes the dynamic traffic information and the expedited transfer indication. I have more detailed slides on each one of them. But these are now separate header extensions from the one that we had previously implemented. And the dynamic traffic information is, for instance, primarily for defining what data burst looks like. And it adds the time to next burst and the burst size in bytes. Then we have the expedited data transfer, which adds data boosting. So, and this shows, for instance, what kind of information you would add then for each. So for instance, you have one PDU set, which is one frame, and then you can see that it marks this information, which is the header, to each of the PDUs. All right, and again, the PDU set cost parameters, which are set for the cost flow. All right, so a bit more detail about the release 19. So this is the release 18 feature we had, which was the RTP header extension. During release 19, we added some more new, so we already had some guidelines for how to set the PDU set importance, which, for instance, based on for different types of media, you would want different information, different importance assigned to different types of frames, for instance. But during release 19, we extended these guidelines. So now, for instance, you have also for tiled HEVC coding, what kind of PDU set marking you can do. So these are guidelines for application servers on how to mark different RTP packets. Then during release 19, we added the expedited data transfer indication. Like I said, this is a new header extension, and this gives a data boosting feature. So if you have a sudden burst of traffic, which has more stringent requirements, so it requires lower latency and higher bandwidth, you can mark these packets with this expedited data transfer indication, and then temporarily the network will switch the traffic to a high precedence cost flow. That means it would have more stringent 5QI, which are the packet delay budget and the lower packet error rate, for instance, that you can ask for a temporary period of time when you have some important information. Then we also added this header extension for dynamic traffic characteristics. So a bit more detail on this one as well. So like I said, in release 18 already, we only had the end of data burst indication. Now we have a separate header extension that also provides the time to next burst. So you know exactly how long it will take until more data is going to arrive. And you also have data burst size. And these are used for optimization of UE power utilization, and also helps the RAN do some better radio resource management. Then finally, we have the handling of N6 unmarked PDU sets. So you might have on the same flows, in addition to RTP, you might have other protocols, for instance, RTCP stun that cannot be marked within RTP header extension, and then you can have your application function assign PDU set importance for these N6 unmarked PDUs. And this PDU set importance can, for instance, be in the same range that you use for your RTP packets, so that not always these packets are the ones that are dropped on the network. They can be given a higher importance when they are some more important, for instance. So yeah, these are the main three features that were added during release 19, and that's the end.